Alright, hello guys. In this video, I would like to teach you on how to do evaluation or evaluating the problems on operator D. So we have this problem which is 1 over d squared minus 1 reactant to 16 16 e to the power of t and then cos 2t. Now, if you can see this problem, or if you can see this operator D, you can just clearly see that we have a function. It's something like a 1 over a function of D, and then it is related to e to the power of x, and then it is it's f at x. Okay, so our f at x is a cos 2t, and then our e to the power of x is e to the power of t, and then there is just a constant. Okay, so here we will apply a theorem 2. So the theorem 2, if we can just recall, theorem 2 says we just need to take this a to this side, ax, and then times 1 over a function of d plus a, and then reactant to a function of f at x. So this is how we solve, or this is how we approach theorem 2. So it is exactly what we supposed to do here. So what we are going to do, we're going to take this e to the power of t aside, and then we apply a theorem 2. So we'll say d plus 1, because we can see this is our 1 here. So we'll have d plus 1 all squared, and then minus 1, and then it's reactant to 16, and then we have a cos 2t. Okay, and then we simplify here, so we have e to the power of a t, and then it's 1 over, so d times d, so it will be d squared, and then d times 1, it will be d, and then it will be therefore plus 2d, and then 1 times 1, it's 1, minus 1, and then it's 0. So we have a 16 here because it's just multiplication, and then we have we are left on reactant to a cos of a t. Now, into esekumele siyenze la is to apply a theorem 2, a theorem 3, because we can just see ukuthi la sinobani sine trig function, and whenever we have a trig function, okusho ukuthi sesinobani, sesino theorem 3. So theorem 3 uthini? Uthi theorem 3, if you have 1 over a function of a d squared reactant to cos of ax or a sine ax. So what is it that you need to do here? You will have a 1 over, instead of a d, and then you put what? You put a negative a squared, okay? And then the reactant to cos ax or a sine ax. So the trig function will just remain here. And the thing that you need to note, noma into ebalulekile mhlambe ama-student iphutha alenzayo kakhulu, is to ukuthi afanise u-negative a squared nobani no negative a all squared. So leya nto leya ayifani. So i-student sigcine sisibhala leya nto leya. So kumele we-apply leya nto leya, but kumele u-apply yiphi? Kumele u-apply leya. So this part, negative a squared, is not equal to leya nto leya. So you must take note of that, ungayenzi no mistake leya, so that uzokwazi ukuthi pass. Alright, so this is just theorem 3, there's nothing much, so we just need to apply theorem 3. And there must be u squared in apaya. Yeah. So if there is no squared, but if there is no squared, we must make sure and try by all means to manipulate the problem here to even squared. Okay. So in this case, we do have squared. So we'll say e to the power of t, and then 16 over negative 2 squared, because our a is 2, so we have a negative 2 squared, and then we have what? We have a 2d, and then reactant to cos 2t reactant. Okay, so the answer here will be what? Will be e to the power of t, and then we have 16 over 2d, and then minus 4. Now looking in this problem, we have a common factor, the common factor of 2. Okay, so we're going to take it out. So we have e to the power of t, and then we have a 16 over 2. We take 2 as a common factor, and then we are left with d minus 2, and then reactant to cos 2t. Okay, so we have what? We have e to the power of t, and then 16 divided by 2, and that will give us 8, and then we say d minus 2, and then we'll be only left with this one, and then we say reactant to cos 2t. Okay, now siqhubeka kanjani ke lapha? Yini ekumele siyenze lapha? Uma sibuka lapha ayikho enye into esingayenza noma into esinayo rather than theorem 3 again, yabo. We still have theorem 3, asikwazi ukuthi siqhubeke siphambili, but singaqhubeka kodwa ngobani? Ngo-theorem 3. So into ekumele senze lapho is to apply theorem 3, but now we have this problem ukuthi we do not have d squared, because it's in theorem 3, it's kumele ngibe ne-function of d squared noma ngibe no-1 over a function of d squared. So into esizoyenza-ke, looking at the denominator, we have d minus 2, so we're going to multiply, or we have to find the conjugate. The conjugate will be a d plus 2 to manipulate and have a d squared. So we're just going to do that. So we'll say a d minus 2, and then times a d plus 2 all over a d plus 2, and then reactant to cos 2t. Okay, so we have e to the power of t, and then we have 8, and then we can just leave this one here, and then we have what? D times d, it will be d squared. This is just a simple of a difference of squares, so it is d squared minus 4, and then reactant to cos 2t. So now we have the d squared, so we are going to apply a theorem 3. We ignore this d, we just leave it like that, and then we will see everything will just simplify on its own. Okay, so we have e to the power of t, and then we have 8 over a negative 2 squared. We're applying a sizela, negative 2 squared, and then minus 4, and then we have d plus 2, and then the brackets, and then of course reactant to cos 2t. Okay, so this one negative 4 minus 4, it will be a negative 8, and then 8 divided by negative 8, that will be negative 1. So negative 1 times e to the power of t, it will be a negative et. Okay, and then we are left with what? We are left with d plus 2 reactant to cos 2t. So what's left now is to just distribute this. We look for a derivative of cos, and then we say 2 times cos 2t. So the answer will be negative e to the power of t, and then the derivative of cos, it's a matter of like distributing this one to this one, and this one to this one. So this is what we are going to do. So d times the cos, which is a derivative, it is the operator, a derivative of operator, or operator of a derivative, and as well as the integration, which is 1 over d. So we'll have what? We'll have a negative sine, 2 sine 2t, and then we have a plus 2 cos 2t. Okay, so we then just distribute if there is a need, but I don't see a need to distribute, but if you like, you can just distribute this negative et. But this negative et won't have any effect, so anyone can just end here, or you can just continue and say, oh, you will have a 2 in e to the power of a t, and we have a sine 2t, and then we have minus 2 and e to the power of t, and we have a cos 2t, but there is no need. But instead, you can even take this 2 as a common factor, you take it out. So this is the answer. So we have covered here, we have covered a theorem. We've covered theorem 2, we applied theorem 2, and also we applied a theorem 3. Okay, we'll do number 2. So on number 2, we are given 1 over d squared plus 10 reactant to the roots of 10 sine root of 10 x. Okay, so how do we approach this problem? So number 1, you need to check which theorem le wena unikezwe yona. Aqale abheka ukuthi yiphi le theorem le unikezwe yona. So ukuqala nje into kumele uyazi ukuthi kumele wazi ukuthi how do you identify ama-theorems? Wabona kanjani i-theorem? U-theorem 1 ubonakala kanje, u-theorem 2 ubonakala kanje, u-theorem 3 ubonakala kanje. So ubonile-ke lapha kule problem yokuqala, I think besinento ekanje. Besino 16 reactant to 16, besino 1 over a function of d, and then reacted to 16, and then it's e to the power of t, and then sasesaba no cos 2t. Yeah. So there is a cos, but there is also e to the power of at. Yeah. So in this case, there is a theorem 2 that we need to first do, and then there is a cos. Yeah. So kule case le esinayo njengamanje asinaye e to the power of e to the power of at. But we only have a constant, which is the root of 10, and then we have a sine root of 10x. And that is what? That is a theorem number 3. So we're going to follow theorem number 3. How do we do theorem number 3? And then we follow those steps, and then we achieve the answer and see what is the total number. Okay, so ascending. So theorem number 2, instead of d squared, we say 1 over a minus what? Minus a root of 10, and then squared. Okay, and then we have what? We have a plus 10, and then reactant to the root of 10 and the sine root of 10, 10x. Now, noticing this, the answer here, the root of 10 all squared is 10, and then minus 10 plus 10 is 0. So we have something which is some sort of a case, a certain case whereby theorem 3 fails, or theorem 3 breaks down, and we need to apply the complex form, and then we then apply theorem 2, okay, to solve this problem. So we need to say a theorem 3. Maybe let me just write as theorem 3 fails or breaks down. Okay, as a theorem 3 breaks down, we then use a complex form. So we just need to note this one as well. A complex form and we apply theorem 2. So this is the case. So it is a case 3. So case 3 says, as a theorem 3 breaks down, or theorem 3 fails, we then use a complex form and we apply a theorem 2. Now, what is the complex form? Complex form, you will remember, we talk about the complex numbers in S1, so I won't go or dive deep on the complex numbers, but I will just say what you need to do if you have something like this, if the case 3 breaks down. So you will have e to the power of j theta is equal to cos theta plus a sine of theta, where this cos theta represented the real, okay, and this sine represented the imaginary. Okay, so we have a sine, and therefore we will apply the imaginary. So we are using the imaginary. Our solution will be based on imaginary parts, not on the real parts. Okay, so you must take note of that one. Okay. Okay, then we then continue, and then we write our problem, and then we say, our imaginary, it will be 1 over d squared, and then plus 10, and then a reactant 2. Now this part is now gone, but there will be what? There will be the root of 10 e to the power of our theta is what? Is the root of 10. So it will be a j root of 10. Okay, so we have something like that. So we are not going to put x. Okay, so we just put a j root of 10. Oh, sorry, a root of 10 x, because remember it will be e to the power of ax. Okay, so we put that x there, and then from here we then apply theorem what? Theorem 2. So what are we going to say? We say the imaginary, and then we say e to the power of j, the root of 10x. And then let's see it is 1 over what? 1 over we are applying a theorem 2, so it will be d plus a root of 10 all squared. Okay, the root of 10j, sorry, the root of 10 d plus a j root of 10, and then plus 10. Okay, and then we say a reactant to the root of 10. Okay, and then we say equal to. Okay, so we simplify this part, so we have an imaginary, and then we have e to the power of j, the root of 10x. Okay, so it will be 1 over. We then expand here, so we just say a d plus a j, the root of 10, and then we have what? A d plus a j, the root of the square root of 10. So it's d times d, so which should be a d squared, and then d times a j, and then as well as d times j, then we add them together, so we will have something like a 2j, the root of a 10 a d, and then we have what? We have this part, which will have a j times j, which is a j squared, and then the root of 10 times the root of 10, which is a 10. Okay, and then we know that the j squared is equal to what? A negative 1, and then times what? Times 10, and then we will end up here having what? We'll end up having a negative 10, and also plus plus this 10. Okay. Okay, so we have what? We have imaginary and e to the power of j, the root of 10x. Okay, and then this cancelled with this one, and then we are only left with the 1 over d squared, and then plus 2j, the root of 10 d. Now, our reactant is now a constant. Okay, our reactant is a constant, and we know that this is a case number 1. Okay, it's a case number 1. So what does case number 1 says? Case number 1 says, if you have a constant, you introduce the factor of e to the power of 0 x. Okay, and then you apply a theorem 1. Okay, so that is what we are going to do. But before we apply that, we need to take out this d, and then we put it aside. So we have what? We have imaginary, and we have e to the power of j, the root of 10x, and then we take out that d. So we have 1 over d, and then lastly, then we have 1 over d, and then plus 2j, the root of 10, and then we have what? The root of 10, and then we introduce the factor, which is the e to the power of 0x, e to the power of 0x, and then from here we then apply the theorem 1. Okay, so when we apply the theorem 1, we will have a lim, imaginary, not a lim, so it's e to the power of j, the root of 10x, and then we have 1 over d, and then we have 1 over 0 plus 2j, the root of 10, and then we have a reactant of a reactant of root of 10. Okay, and then when we continue here, we will be left with, let me just write it, we will be left with the imaginary of e to the power of j, root of 10x, and then times 1 over d, and then we have 1 over 2j, the root of 10, and then you'll notice that there will be a root of 10. We just multiply this one times this 10, and then what will happen here, and then this will cancel, this 10 will cancel this 10, and then we are left with what? We are left with imaginary parts of j, root of 10x, and then we have 1 over d, and then we have what? We have 1 over 2, if you can check, and then we have what? 1 over j. Okay, so you need to note that the 1 over j is equal to negative j. Okay, so we're gonna substitute here. So we have equal to the imaginary and e j root of 10x, and then we have 1 over d, and then times 1 over 2, and then we have a negative j. Okay, and then we have that, and then this is j, so it will be imaginary e to the power of j, the root of 10x, and then we integrate this, so we can just take or we can just put it back, a negative what? A negative j over 2. Okay, and then we then integrate, so we'll have what? We'll have a lim e j root of 10x. The integral of this part will be what? It will be negative j over 2x. Okay, all right, and then so you must remember this is a multiplication, and then we write this part, go back, we say, oh, it will be a cos, the cos of what? Of a j, the roots of 10, okay, and then what? And then plus a j sine of a j roots of 10. Okay, so we're going to substitute that and then we multiply. So we have what? We'll have a cos. We have a cos a j roots of 10, and then we have a plus a j, and then j sine of the j roots of 10, and then times with what? Times with the negative a j 2x. Okay, and then if we times here, so we have what? We'll have this times this, so we'll have something like a negative 1 over 2, and then we have a j, and then we have a j cos of j. Is it j there? So it must be the root of 10, not a root of 10 x, and then there is the root of 10x as well. Okay, and then so we have a root of 10x, and then what is this? This will be a minus. Okay, this will be minus because it's a positive times a negative. Okay, this is a negative, and as well as this one, it's a positive times a negative, and then it was a negative 1 over 2j, and then as well as on this side it will be a positive times a negative, which is a negative, and then a j times with this j will cancel, and then we'll be left with a half of what? A half of x. Sorry, we also have x here. Okay, so and then we have what? We have a sine of a root of 10x. Okay, so we have the imaginary parts, and we have what? We have a real part. So our solution here will be what? Will be a negative 1 over 2x and a cos root of 10x, and this will be our answer. So if you notice, in the beginning we had the sine. So since we had the sine, most of the cases, or every time, it will change to cos. If this was a cos, then it will change to sine. Okay. Sakubega, number 3. We're doing number 3. Okay, so we are now doing a general solution of operator D using the skills of operator D. So we're given a 10 a d squared t, and then dt squared, and then plus 10 di over dt, and then plus I over 0.025, and then it's equal to 100 a sine t. Okay, so this is the general solution, which can be 15 marks, 18 marks, whatsoever. So it is a very serious a problem if you will get it in your exam or in your test. So you just need to know it very well, and you need to know step by step. Okay, so I'll just break it down. How do we approach this problem before I even start an attempt? Okay, so number 1, we need to find the complementary function. Okay, number 2, we need to find the particular integral, and then number 3, which is the lastly, we are looking for the general solution. So the general solution is whereby we are combining or we are looking for the sum of the two, the complementary function and the particular function. So I'll just go dive deep into a complementary function, because when we are looking for a complementary function, we are actually using the skills of the auxiliary equation. So we remember that on auxiliary equation we have some cases whereby m1 is not equal to m2. So what will be your complementary function if your m1 is not equal to m2? And therefore, if you have this case, then you will have your a and e to the power of m1 x, and then we have a plus, and then b and e to the power of m2 and then x. Okay, so it's whereby your m1 is not equal to m2. Okay, so that was case number one. Okay, so case number two of a complementary function, it's whereby your m1 is equal to m2. So we just you can just simply say like this. So your m1 is equal to m2. So what is your complementary function, or what is expected for on the complementary function? So what is expected is that the complementary function is equal to a and e to the power of m. We just write m because the m1 is basically is equal to m. Okay, so just write m, and then say a plus, and then we say b, and then we must write x there, and then we say m e to the power of mx. So it look like this. So the difference, you can see there is a b and e to the power of m2 to the power of x, and then here we have a bx. Okay, so this is the cases where the m1 is equal to m2. Okay, and then number three, it's whereby your m is a complex number. So once you get the complex number on your auxiliary, so we just need to know how to approach, or if you get the undefined, or let me just say the complex numbers. You know, how do you approach and how your complementary function will look like. So you have y cf is equal to it will equal to e to the power of alpha x, and then we have your a cos beta x, and then plus you have your b, and then we have your sine beta of x, and your complementary function will look like this, and where your m, you will get your m on the auxiliary, which is equal to the alpha plus or minus a j beta. Okay, so you will get something like this if it is a complex number. Okay, where this real part represented the alpha, the angle alpha is represented as an angle, and then the beta, which is the imaginary part, which is this angle there, here and here. So this is how you apply a complementary function. Okay, on number two, we must find a particular function. A particular function is always a 1 over a function of a d. So I'm going to show you how to find this function of d from here. So we are going to achieve that, and then reactant to anything that is given, but I'll just simply use the f(x), which is the function. So it's any function that you might be given. So it can always depend on the function, or let me just say any theorem that you might be given, and then you just apply those skills from there. Like for example, here we just given 100 sine 2t. So this part will be on this part, and then you just know, oh, okay, it is a theorem 2, and then you just apply those skills of a theorem 2. Okay, so and then the third part, which is the last part, is whereby we are finding now our general solution, which is y of a complementary function, and then plus a y, which is a particular integral. So then we are done. You get your full marks, and that's all. You just pass. Okay. So we're just gonna start this problem. We break it down, and we see what is given, what is not given. We just focus on what is given. Then we solve step by step, and then we go and write our test or our exam and pass. Okay, so into ekumele yenzeke la is that the coefficient, this must be 1. Okay, this coefficient must be 1. So into ekumele siyenze lapha, we just need to divide, and we just need to divide by 10. Okay. Alright, so we just need to divide by 10, and then we get the answer, and then we can also fix this and try to see if we get the number. If we get the number, then we just simplify it. So let me just check. So we have 1 over 0 point, so it is a 1 over 0, 0, 2, 2, 5. So this is 40. So you can simplify this. So it should be a 10 d squared t over d squared, and then plus 10, and then di over dt, and then plus 40, and then I, and then it's equal to 200, and then sine 2. I think that's the first step. The second step, or it can also be a first step whereby you are just dividing, and then you just see the answer. So we just divided by 10. So you'll be left with d squared dt over dt squared, and then plus di over dt. Okay, and then plus 40 divided by 10. So it will be 4. So it's 4i, and then it's equal to. And also on this side, so you say 100 divided by 10, which is also 10. Okay, so we have a 10 and a sine 2c. Okay, so we have now our standard form of this equation, and then what do? We look for auxiliary. Okay, which is whereby we are looking for the complementary function. Okay, so we say instead of the d of di, basically we say a di over a dt will equal to m. Okay, so then we will have what? We'll have a m squared, and then plus m, and then plus 4, and then we say equal to 0. Okay, so looking at this problem, if we need to factorize here, find the factors of 4, that when we are looking for the product of those factors, they give you the delta, but when you add those factors, they give you the middle term. In this problem, this is impossible. So we just need to plug in the quadratic formula, which is m is equal to negative b plus or minus the roots of b squared minus 4a, and then all over 2a. So it's now clearly see, or you just need to see that by using this quadratic formula or equation, you will get the complex numbers. So most of the time, or most of the cases, when you are using this part, where there is no factors, it's whereby you will get the complex number. So we are using that case of the auxiliary. Okay, so we just need to substitute. So we have m is equal to negative b is 1, and then plus or minus the roots of 1 squared minus 4a, there is c here, and then our a is 1, and then our c is 4. Okay, and then we have our 2, our a is just 1. Okay, and then we have our m is equal to, and then is equal to negative 1 over 2, and then it's plus or minus, and then there's 1 squared, which is 1, and then there's 4 times 4, which is 16, and then 1 minus 16 is negative 15. Okay, so we'll have a negative 15 over 2, but we know that the negative 15 is equal to the roots of negative 1 times the roots of 15, and we also know that in complex numbers the square root of negative 1 is simply j, and then j times root of 15 should be a j root of 15. So the answer here will look like this. So it will be m is equal to negative half, and then plus or minus a j root of 15 over 2. Okay. Alright, so this is our complex number. Remember, your m goes like this. It is an alpha, a plus or minus, and then it will be a j, and then it's a beta. Okay, so our complementary function is what? Is a e to the power of an alpha and an x. Okay, but here we do not have x. That one you need to take note of that one. We are given as a di, so it's di over dt. So it seems like same as a dy over dx. Okay, so here we will write not x but a t. Okay, and then we open our brackets, and then we have a cos beta a t, and then plus a sine a beta of t. Okay, and then we just need to substitute. Okay, so we have a y complementary function is equal to, and e to the power of the alpha is negative 1 over 2, so we have a negative 1 over 2 t, and then we have our a, and then we have our cos, our beta is the roots of 15 over 2, the roots of 15 over 2 at c, and then plus we have our b here, and then this is our b, and we have our sine. So it's not beta but b, just a b. So b for bendy. Okay, so it's sine. Then our beta is roots of 15 over 2, and then c. Okay. And then we continue. So this is our complementary function. We used the complex numbers that I explained earlier on. Okay, sharp. So now the second step is to find the particular integral. Okay, so what we are going to do here, we're going to start from here. We use this one, so we will have a d a squared I, and then plus a di, and then plus a 4i. Okay, and then is equal to 10 sine 2t. So what do we need to do here? Okay, because our our complementary function, our particular integral must be the current. Okay, so we need to take this current aside as a common factor, so that we will find the current, or make the current as a subject of the formula. So the question was saying find the general solution, the current equation of this in terms of t. Okay, so we just take it out at t, and then we are left with a d squared, and then plus a d, and then plus 4, and then equal to a 10 sine 2t. Okay, and then we just need to make this as the subject of the formula, and then we divide by everything, and then we will end up having 1 over d squared, and then plus a d, and then plus 4 reactant to 10 sine 2t. Remember, I said your complementary function or particular integral, so you can put this one, it will be a 1 over a function of d, or reactant to 10 sine 2t. Okay, so we can just simply erase this part. So we have a particular integral of 1 over d squared plus a d plus 4 reactant to 10 and a sine 2t. Now, looking at this problem, once you have something like this, or you are given something like this, they say evaluate. The first thing, as I have said, you just need to identify the theorem that is given at that time. Okay, so the theorem that is given here is just a theorem number 3. We have covered theorem number 3. We know what is expected from us when we solve for a theorem number 3. Okay, so we just apply that one. We have our a, which is 2, and then we have a d squared. So we don't have problems, so we just apply that one. So we have the current particular integral, and then it's 1 over a negative 2 squared, and then we have plus a d, and then plus 4, and then the reactant, and then it's 10 a sine 2t reactant. Okay, wait a minute. This one is negative 4, and then this one is positive 4, and then these two, they just simply cancel. Okay, so we are left with what? A particular integral of 1 a d, and then we have a 10, and then we have a sine 2t. Okay, and then from here there's nothing we can do much. We just need to integrate. Okay, so we find there the integral of a sine 2t. We take this 10 outside because 10 is a constant, so we can just do that. So the 10 is outside, and then we integrate sine. So if we integrate sine, we will have what? We will have a negative of what? A negative of a cos 2t all over 2. Okay, so the answer will be we then say, oh, there is 2 times 5, and then there is this 2, and then 2 will cancel with this 2, and then we will be left with 5 cos 2t. Okay, so this is our a current, a particular integral. But now we were asked to find the general solution. Okay, so it will go like this. It will be a complementary function and plus the current of a particular function. Now there is a mistake here. You don't put y's because we are not given a dy over dx, and this will become incorrect because you have now put the y's. Okay, so it's not a dy over dx, but it is di over dt. So we must represent this as a current as well. Okay. Okay, sharp. So we then substitute this is equal to this whole thing, and then this is equal to this part. So we can just do that. So it's negative 1 over 2t, and then into a, and cos root of 15 over 2t, and then plus a b, a sine root of 15 over 2t, and then minus 5 cos 2t, and then this is your general solution.